Welcome back, DH Crew. Today's hurdle is Algebra Made Simple, Part 2. Let's get over this hurdle. Hey everyone, this is Paula from Daily Hurdles. Today we are continuing in our algebra series. In Algebra Made Simple, Part 1, we went over the importance of committing those basic mathematic fundamentals to memory, as well as the first rule of algebra: whatever is done to one side of the equation has to be done to the other side of the equation to maintain equality. If you haven't seen Part 1, I urge you to go back and watch that video first. Now, let's move on to a few more algebraic rules that will add to the basic foundation that we are building. The first few are fairly simple. You probably already know them. We're just going to give them a name. First is the additive property of 0. Simply stated, n plus 0 equals 0 plus n equals n. Well, what does all that mean? Any number plus 0 equals 0 plus any number equals n. Let's give it a number. 4 plus 0 equals 0 plus 4 equals 4. So all of this means is anytime you add 0 to a number, it equals the number. Simple. The next rule is the multiplicative property of 1. Simply stated, any number times 1 equals 1 times that number simply equals that number. So any number multiplied times 1 equals that number. 4 times 1 equals 1 times 4 equals 4. So you can see these first two properties are kind of connected. If I add 0 to a number, it equals the number. If I multiply a number times 1, it equals the number. The next property we'll go over is the additive inverse property. This is one of my favorites. Any number plus its opposite equals 0. So what this is saying is any number, so we'll take 4 again because that's one of my favorite numbers, plus negative 4 equals 0. The next property we'll talk about is the reciprocal property. What is a reciprocal anyway? A reciprocal of any number is the number that you would multiply it by to get 1. Kind of like its opposite. It sounds complicated, but it's actually pretty simple. Let's take the number 5 for example. 5 times 1 over 5 equals 1. 5 times 1 is 5 over 5 equals 1. What would be the reciprocal of 8? 8 times 1 over 8 equals 1. How about 0.75? Simple. Times 1 over 0.75 equals 1. Now let's get a little trickier. How about 3 over 2? What number would you multiply that by to get 1? Again, we're talking about opposites. Let's look, what would the opposite of this be? 2 over 3. So when I multiply 3 times 2, I get 6. 2 times 3, I get 6. 6 over 6 equals 1. If you simply can't figure out the reciprocal of a number, you can always go back to what we learned in Algebra Part 1 Made Simple. And you can set up an equation. 5 times what number, n, equals 1. So we want to know what number do we multiply by times 5 to get 1. So we just do it the way that we learned before. We divide this side by 5. We divide this side by 5. This becomes 1. We end up with n equals 1/5. The next property we'll go over is the commutative property of addition. Simply stated, A plus B equals B plus A. So what is that telling us? It's telling us that it doesn't matter the order that we add things in. If I have 3 plus 5, it's going to be equal to 5 plus 3. 8 equals 8. Even if I have more than one, I can have 3 plus 5 plus 4, and that will equal any order 5 plus 3 plus 4. It'll also equal 4 plus 5 plus 3. So the order that we add things in doesn't make any difference to the outcome of the equation. This same property holds true for multiplication. If I have A times B, it's the same or it's equal to B times A. In our standard terms, 3 times 4 equals 4 times 3. If I have more, 3 times 4 times 5 equals 5 times 4 times 3. Keep in mind, the commutative property works with addition and multiplication. It does not, however, work with subtraction or division. So we cannot say that A minus B equals B minus A. If we have 5 minus 4, it does not equal 4 minus 5. 1 does not equal negative 1. Same goes with division. A divided by B does not equal B divided by A. 6 divided by 2 does not equal 2 divided by 6. Of addition is the next property that we'll talk about. This one has to do with the order in which we add numbers. So it's simply stating that if I have 3 numbers, A, B, and C, if I add these 2 together and then this one, it equals the same as if I add these 2 together plus this one. So simply stated, we have 2 plus 4 plus 3 equals 2 plus 4 plus 3. So we have 2 plus 7 equals 6 plus 3, 9 equals 9. So again, it doesn't matter how we group them together, the answer is going to come out the same. The associative property of multiplication works the same as addition. So here it states I can multiply the second 2 numbers together and then multiply the third. It will equal the same as if I multiply the first 2 together, then multiply the third. So we have 4 times 3 times 2 equals 4 times 3 times 2. If I multiply these 2 together first, I have 6 times 4. If I multiply these 2 together first, I have 12 times 2, and they both come out to 24 equals 24. So it's easy to see, it doesn't matter which order that you multiply the numbers in. Again, keep in mind that the associative property does not hold true for subtraction or division. So 12 minus 6 minus 2 does not equal 12 minus 6 minus 2. So 12 minus 4 does not equal 6 minus 2. 8 does not equal 4. The same holds true for division. 12 divided by 6 divided by 2 does not equal 12 divided by 6 divided by 2. Let's work it out. 12 divided by 6 divided by 2 equals 3, does not equal 12 divided by 6 equals 2, divided by 2. 12 divided by 3, 4, does not equal 2 divided by 2 is 1. The last property we'll look at today is the distributive property of addition over multiplication. Written out, it looks like this. A times B plus C equals A times B plus A times C. So let's see how that looks with real numbers. 2 times 4 plus 5 is equal to 2 times 4 plus 2 times 5. So here we have 9 times 2 is 18. On this side, we have 2 times 4 is 8. We have 2 times 5 is 10. 8 plus 10 is 18. So in real numbers, you can see that this property does work. You may ask, why do we even care about this? Well, there are times when you're given an equation that you can't add the variables inside of the parentheses, like this. 2 times 2n plus 3 equals what? Well, now you would want to distribute this because you can't add these two numbers together. So this would be a good example of why this property is necessary. So we're going to just do the same thing. We're going to do 2 times 2n, 2 times 3. So this equation would come out to 2 times 2n plus 3 is equal to 4n plus 6. This property is going to come in handy down the line when our equations become more difficult. Well, I think I've given you enough information for today. Study these properties and commit them to memory, because they are the next building block in our algebra foundation. I have included a practice sheet for these properties on dailyhurdles.com in the tutorial section. Thanks for joining me today. Come back and check out some more of our instructional videos. See you soon.